Okay, so we're trying to get the inverse of this function. So for simplicity, I'm just going to change f of x to y. So y equals x squared minus 4x minus 4. And they're saying, which is important here, that x is greater than 0. Or sorry, x is greater than 2. Okay. Now, so what we have to do next of all is to get the inverse of a function. We know we have to change the x's and the y's. So interchanging the two of those, we get x is equal to y squared minus 4y minus 4. And obviously now y is greater than 2. Now, generally, that is the answer for the inverse function, but we would like to be able to write f inverse x equals, okay? And in order to be able to write f inverse x, we need to get I isolated on its own. Okay, get y isolated on its own. Now we can see here that we have a y squared and we have a y, so it's going to be very difficult for us, or it's impossible in fact, to get y on its own in this situation. But we should know from previous experience that if we write it in perfect square form, or sorry, completed square form, that means we will have a single y. So that's exactly what we're going to do here. So I'm going to write this as x equals y squared minus 4y, and I'm going to add minus 2 squared, and I'm going to subtract minus 2 squared, and not forgetting I still have this minus 4 at the end. So like before, I put my three first terms together as my perfect square, which in this circumstance is y minus 2 squared. I then have the next part which says minus 2 to be squared, which is going to give me minus 4. And I also have this minus 4 at the end. Okay, so x equals this. Okay, so now just tidying it up at the left, on the right, we have y squared, y minus 2 all to be squared, minus 8. So now we have an isolated y, so we'll be able to get this y on its own. So the first thing we're going to do is we're going to bring that 8 across to join the x. So we get x plus 8 equals y minus 2 squared. Okay. Next thing we need to do is we need to get rid of the squared, so that will get the square root. And remember, when we get the square root, we have to go plus or minus equals y minus 2. And now finally our minus 2 needs to be removed, and we'll get 2 plus or minus the square root of x plus 8 equal to y. Now at the moment we have a problem, because now this function, well, this won't be a function because each y has now got, each input is giving out two outputs, because what we have here is we have a plus or minus. So this is a problem. Do we need to deal with the plus version or do we need to deal with the minus version? Well, if we go back up and look at our equation, we can see up here at the top that our y's have to be greater than 2. So the only way that our y's will be greater than 2, if we're adding and subtracting from 2, will be if the square root of x plus 8 is positive. So that tells us that we need to go with 2 plus x plus 8 to give us y. Okay, because we've stated up here that y was greater than 0, and that happened when I swapped my x's and my y's. Okay, so then we can just say this implies that our inverse is equal to 2 plus the square root of x plus 8. Now, the question also asked us, it has a domain where x is greater than 0. It says, and write down the range of the inverse function. Now, I've actually written that already, because if we look up here, the domain was x greater than 2, but when we swapped the x's and y's, we got that y's must have been greater than 2, because what was the domain now becomes the range when we swap out. So this implies that the range is y greater than 2, because what was the domain has now become the range.